Hi, everyone. Tim Takaro, and I'm on unceded territory of the Coast Salish in British Columbia. And I'm really happy to be presenting a little bit of our work over the course of Canoe in the weather and climate change working group. And I'm even happier that I will be doing the presentation because Jordan Brubacher, who is a graduate of our program and Masters of Science in Health Sciences, will be presenting the projects that he largely did the work for. With that, I'll just turn it over to Jordan and look forward to any questions that you might pose to us by email.
Thank you, Tim. Hi, I'm Jordan Brubacher, and as Tim said, I'm in the Faculty of Health Sciences at Simon Fraser University, and I'm in the environmental health field, looking at many different topics related to climate change and health, and a whole slew of others. And so I'm looking forward to introducing you to a few of those projects today. So first, I'd just like to acknowledge some of the people who've helped us along the way. There's been many more than you see here, but these were just some of the predominant ones. Johanna Fedema, Stephanie Gower, Rafik Saskin, Jeff Kwong, Kelly Sabaliaskis, Eleanor Sitton, Pei Wang, and Andre Redivo. So the first project I'd like to mention is it was an opportunity to bring together members of the Canoe Network to meet with some of the people from the Environment Community Health Observatory Network, otherwise known as the ECHO Network. And the ECHO Network is a pan-Canadian group looking at the impacts of resource development on rural, remote, and Indigenous populations. So the meeting was a one-day opportunity to discuss the merging of big data and data-intensive approaches within the research on environmental health and equity field. It's an up-and-coming opportunity to really harness some of this potential. At the moment, there's a manuscript being developed looking at intersectionality and GBA plus approaches to producing a new generation of equity-informed approaches to understanding the impacts of climate change on equity-deserving populations. The next project I'd like to introduce you to was looking at the urban heat island effect across Canada. And this study utilized the local climate zone data from Canoe. And this data was combined with Environment Canada Weather Station data. And basically what we're trying to do is calculate the number of cumulative hot hours, which is, in this case, the number of hot hours above a 95th percentile or 99th percentile. And this is just to really get a good indication as to what is the urban heat island effect across the different local climate zone groups. And what we did was we actually took stations that were located within ecoregions that shared a similar macroclimate so that these stations could be compared to one another. So it limited us to the number of stations we could ultimately include. And the ones you can see here in purple are the ecoregions that did have enough weather stations that were in at least 2 local climate zone groups. And just for those of you that are unfamiliar with local climate zones, they're basically kind of like what you're seeing here with ecoregions that describe regions of similar macroclimates in Canada. The local climate zone groups are sort of this urban designation for microclimates within the built environment. So the results we're looking at here are, you can see the ecoregions across the bottom represented by their numbers, and then the local climate zone groups as the bars, with the whiskers representing it. There is more than one Environment Canada weather station in a group. We were able to put in some error bars there to reflect that. And as you can see, most of the ecoregions only had 2 local climate zone groups. Some of the more urban ones did have, we could start to see some of the more industrial, commercial, paved, residential groups we're starting to see more of. But by and large, you know, there wasn't a lot of data to work with. So some of the results that we sort of anticipated that were reflected in the data was that the industrial, commercial, paved local climate zones did have higher heat hours. So there was this urban heat island effect that you can expect with a lot of pavement and big buildings and very few trees. And then similarly, the water local climate zones had a low number of heat hours, and this is to be expected because the water really just absorbs heat and doesn't do a great job at releasing it. So some of the more surprise results were related to the natural local climate zones that did have a higher number of heat hours than we sort of expected when compared to the residential local climate zones that actually had a lower number of heat hours, given that residential areas should have more cement and other built features that would store energy, and the natural local climate zones would not. So that was a little bit surprising. But overall, there wasn't enough weather stations to really do a real good job of this analysis. So in the future, we would recommend considering using crowdsourced data from Weather Underground or some other similar opportunity that provides a lot more data at a very fine resolution. So the next project I'd like to speak about is the NDVI land cover and local climate zone work we did in Toronto. And again, this was utilizing Canoe data, the local climate zones that you can see there, but also the NDVI data, which is the Normalized Difference Vegetation Index, otherwise known as greenness. It's really commonly used in the health research when looking at impacts of the environment on health. However, it really suffers in the ability to differentiate between different types of vegetation. And so for that, it's been criticized on a number of fronts. And so what we've tried to do here is to look at correlations between NDVI and tree cover and between NDVI and grass cover across the different local climate zone groups to see if we can, if there's any potential to use local climate zones as a bit of a proxy when you don't have this really great high resolution land cover data that we had available for Toronto, which was provided by the US Department of Agriculture. So it was a good opportunity just to explore these correlations. And what we found was that NDVI was, generally speaking, more correlated with trees than with grasses and shrubs. And that's, you know, sort of to be expected. That's the literature generally assumes higher NDVI values are more related to trees. However, you can see that those correlations did basically match each other in the open urban local climate zone group. So there wasn't much of a difference there. So in the natural, residential, and the water local climate zones, the NDVI was much more correlated with tree cover, whereas in the industrial, commercial, paved, and open urban local climate zones, NDVI was much more correlated with both of them together. So it more of suggesting like a mix of trees, grass, and shrubs. And so we looked at the NDVI data set captured by the Landsat satellite, but we also looked at the MODIS satellite, another data set available from Canoe, and just to see if they were reflected similar patterns. And they did have similar patterns, but the Landsat correlations were much stronger and likely due to the higher resolution of that data. So we sort of reached the conclusion that when using NDVI in epidemiological studies, there is some potential to use local climate zone groups as an additional variable to help sort of control for the different types of vegetation that the NDVI alone is incapable of discerning. So the next project is sort of built upon this first one, and this one also was in Toronto, also included the local climate zone data set, as well as the trees and the grass data set. But we also now brought in additional Canoe layers, including ground level ozone, particulate matter 2.5, PM 2.5, and nitrogen dioxide for air pollutants. And then we also brought in social and material deprivation. And these are two separate data sets. Social deprivation being a measure of social isolation, and material deprivation sort of being the classic income education variable. And all of this we used in a model to look at allergic rhinitis, otherwise known as hay fever or allergies. And all of these variables are known factors. And so we modeled those using a regression analysis. And you can see on the right-hand side, this is the pollen spectrum, or the pollen distribution, I would say, of for Toronto over the course of 4 years or so. And you can see that the trees pollen really dominates that second quadrant there. That's springtime, and then the next section is summer, which is much more dominated by weed pollen, and then the grass pollen kind of straddles the two seasons. So we ran the model for each season separately because of this known seasonality of the pollens, but also the air pollutants have a seasonality to them as well. And we ran a spatial model with a spatial lag factor to account for influences of neighboring factors. And the results here are all the variables were retained that based on their significance level. And we did highlight just the factors or the variables that were actually negatively correlated, because all of the others are positively associated. I'm sorry, whereas these four are actually negatively correlated or associated, which was a surprising result a little bit, especially for trees, which in the summer there is tree pollen and trees are very allergenic, and yet there was actually a protective association found, whereas in the springtime, when there is large amounts of tree pollen in the air, the tree variable was not significantly in the model. So however, the local climate zone group, the natural local climate zone group, contains trees as well as all other types of vegetation, and that variable was in the model for all 4 seasons. And so there's definitely tree pollen being produced, and people are allergic to it, but for some reason, a really high resolution tree variable was not able to capture that. So some really fascinating results. And generally speaking, the findings showed that air pollutants, NO2 and PM 2.5 were positively associated with allergies. Material deprivation was also positively associated. And the local climate zones groups, the natural, the dense urban, and the industrial commercial paved groups were all positively associated as well. And there were, like I said, the few that were negatively associated with social deprivation, meaning the more isolated the communities were, it seemed to be less allergies, which was a really surprising finding that we didn't really see in the literature. So it does warrant some more investigation there. And then the tree cover variable, again, that was had this protective effect in summer. Definitely warrants some additional thinking, and we did include some hypotheses on that in the paper that's currently being written, if you have an interest in reading that at a future date. And most associations only appeared in some of the seasons, and this was the nature of the data being very seasonal. So that wasn't a surprise. The exceptions were the natural local climate zones, which even in the winter, when there's very little pollen, it was still a risk factor, and material deprivation as well. So the natural local climate zone groups, there is some more to be learned there. Maybe there's something about fungal spores, which are potentially allergenic. So there's there's more to unpack there for sure.
Let me
And that was,
just add something there, Jordan, if you don't mind, before you
of course,
wrap up here. And this is about what is allergic rhinitis and the measurement that we took. It is utilization of health services for allergic rhinitis. And that may impact, for example, the findings that we have for social deprivation, where people may not be accessing care, even though there is plenty of allergic rhinitis. So just a caveat for that.
And then finally, the spatial lag term that we added did remove the spatial autocorrelation of the residuals in all 4 seasons, which was fantastic. However, the spatial lag term was only significant in the summer. And so that suggests to us that the neighboring factors, the factors of neighboring, in this case, it was postal codes. So postal codes that are located nearby, factors in those areas did have a bigger influence in the summer on allergies as compared to the other seasons. And this could be related to seasonal changes in human behavior, in wind patterns, pollen fluxes, air pollutants, or some other factor that this study just wasn't capable of looking at specifically. So this study was very interesting. It opened up a lot of possible questions and avenues for future research. And I hope that all of these studies did show the versatility of the local climate zone data set that we've been applying across a number of use cases. And it's really exciting to use. So thank you for that opportunity. Thank you. And we'd be happy to field any questions or comments you might have. And there's my email. Thank you.